question number 4 on the calculus and velocity worksheet. This problem involves being able to recognize that you have to undifferentiate an acceleration function to be able to find a velocity function. So what does undifferentiating look like? Well, if I know my acceleration function is my a of t is equal to 2t minus 1. My original function, to get a derivative of 2t, I have to kind of think that to get a linear function, my original function had to be a quadratic. And this constant value of minus 1 means that the slope on the velocity function must have been minus 1. So that portion must have been negative t. The other part is, well, I have to just make sure that when I differentiate, there's a power rule. The coefficient comes into the front and it affects the coefficient. But when I do this, I get 2t. So it looks like the coefficients look okay here. That's my coefficient. Now, one part of this is when we differentiate a function, if we differentiated a constant, that constant differentiates to 0, wouldn't show up in my derivative. So I don't know if there was a constant here. So I have to account for that. There could possibly been a constant here. But how do I find that constant? In this question here, that constant could be found because we've been given the initial velocity of -4 meters per second. Well, that means then that my velocity function looks like this. V of 0 equals -4 meters per second. And that's calculated using this. Well, what happens if I actually plug in the 0 into that equation? It would be 0 squared minus 0. I have my plus c. And that would be equal to -4 meters per second. Well, that means then that that constant value must have been -4 meters per second. And then by knowing that, I now have solved for my velocity function. So that involved undifferentiating, recognizing that there might be a plus c, and using some more information in the problem, in this case the initial velocity, to be able to calculate what that plus c might have been. So there's my velocity function. So when I have a velocity of -2 meters per second, the position of the particle is 2 2/3 meters. Well, if I want to do that, I need to find my position function, my p of t. Well, maybe I'll just write that as x of t. And to do that again, well, I just need to recognize that this is my derivative. I need to undifferentiate. To undifferentiate a quadratic, I'm going to end up with a cubic. To undifferentiate a linear, I'm going to end up with a quadratic. That has a slope of -4, so that part must be, the linear part must be 4t. I have to remember that there could possibly be a plus c. And that looks okay, but when I actually differentiate this, I'm going to end up with 3t squared. So I have to account for that extra coefficient that's going to end up here. Well, since it's a coefficient, I can account for it this way. The 1/3 will not affect differentiation, so if I just put the 1/3 in there, I'm going to end up with the correct coefficient of 1 and the correct power of 2. And the same thing can be done here. I'm going to end up with 2t. Well, I don't want 2t, so to account for that, I can just have a 1/2 in here. And so this function, if I differentiate it, will differentiate to my velocity function. So there's my position function where I don't know the plus c. Well, I could do the same thing as I did up here, where if I know a time and velocity pair, or time and position pair, I can solve for the plus c. Here I haven't been given time though, I've been given velocity and the position. So I need time. But since I know the velocity and I have the velocity function here, I can actually solve for the time. So I know that my v of t is equal to negative 2 meters per second. And that's equal to this function, t squared minus t minus 4. And I can actually solve this function for t. Make it into a quadratic equal to 0. And I can solve this equation for the time when we have 2 meters per second. If I know the time at 2 meters per second, I can use that same time, because that's the same time as I'm looking for, to calculate the position. So solving for this, I can factor this. So the time is equal to 2 seconds or negative 1 second. Well, I can kind of eliminate that. So my time must have been 2 seconds. So then to find out when the velocity is negative 2 meters per second, okay, so at t equals 2, my velocity, v is equal to 2 meters, negative 2 meters per second. This is what I'm looking for. I'm going to use this t here and plug it into my x function.